Good morning, ladies and gentlemen. Happy Friday to you all. At this time, I ask that you raise your hand if you did not get a red mark for the 9th of October. Is everybody good? Okay, so last class, right, we took an exciting adventure down proof lane, right, and we verified that the derivative of sine of x was, in fact, cosine x, the function that we conjectured through inspection on our graphing calculator. And the derivative of cosine of x is the opposite of sine of x, right? The function that we also developed through inspection using our analytical techniques for sketching a derivative and using our n-derivative numerical derivative calculator in our graphing calculator software. And so the point of that is now we can use those shortcut rules forever on and not have to start with the definition of a derivative. So please be ready to share the result of applying those shortcut rules when I call on you here in these first couple examples. So if y is given by 3x to the fourth minus sine of x, then y prime would be given by what? Allie?
12x cubed minus cosine.
Thank you, and let's check our signs here. Sine positive versus negative. I know that sine differentiates to cosine, so negative sine must differentiate to negative cosine. Good job. Raise your hand if you're the same as Alec. For the same thing. Way to go, you guys. That's exactly right. Number 2, if y is negative 3 cosine of x minus 4 cubed, right, then y prime, the derivative would be what? Go ahead and share with the class. And what did you get for that, Meg?
3 sine of x.
And let's check our signs here again. Cosine differentiates to opposite of sine. Times the negative in front must be a positive, and a constant multiple times the function. Right? The derivative of that is just the constant multiple times the derivative of the function. Nice job. Raise your hand here. The same thing as Meg. You guys good? Awesome. Way to go. For our third one, term by term, the derivative of 3 sine of x minus 5 cosine of x minus pi cubed. And what did you get for that, Paul?
3 cosine x plus 5 sine x.
And notice how Paul, right, the derivative of pi cubed is 0. So we'd include that in our derivative of all. The derivative of any constant is 0. Nice job. Let's check our sign. So sine goes to cosine when differentiated. Good. So that stays the same sign. Cosine goes to opposite. So this is going to flip sign, and then our constant multipliers are there. Awesome work. Raise your hand if you have the same as Paul. Same thing? Woohoo! You guys are doing great. And number 4, right? Number 4, in order to be differentiated, we must first expand that squaring out, right? We don't have a rule that will handle a composite function, right? A composition of functions. And so in order to differentiate our expression for y, we'd first have to algebraically rewrite that. And so we could rewrite our squiggle underlined green as 3x plus 1 times quantity 3x plus 1 in a FOIL problem. First outer inner last would generate 9x squared plus an outer product of 3x when combined with an inner product of 3x would give me plus 6x for the linear term of my trinomial, and my last would be plus 1 times plus 1 is plus 1. So if I now were to differentiate term by term and generate an expression for y prime, I would get y prime equals, looks like 18x to the first plus 6, and then continue on term by term. I know that cosine differentiates to opposite of sine, so that would be minus sine of x, and then the derivative of 19 is 0, so I'm getting nothing there. Raise your hand if you already had number 4's answer. If you already had number 4, the same? Yes, you guys are doing great with your shortcut rules. Excellent. Okay, so we've gone ahead and taken care of those. We've gotten our red marks. Now let's go ahead and check our OTL number 7. So at this time, I'd ask that you make sure your OTL number 7 has a proper heading on top. You need to staple multiple pages together. I think we had some more graphs. So if you kindly staple your half sheet together, and Evie, I'll start that with you. Make sure that you give yourself credit for those that you complete out of 19. Divide, enter, multiply by 2. Staple your half sheet on there. Make sure we can see your name and score. And box that Infinite Campus. Score nice and big round to the half point. Okay, thank you for coming. Final check that your name is on there. Your OTL score for Infinite Canvas is box nice and big. stapled multiple pages together, and then go ahead and pass them back to front, please. Front rowers, if you make sure they're facing the same direction, that'd be awesome.
No.
Thank you.
Yeah, that makes it work.
Are we good with OTL number 7? Number 7? Awesome. Okay, ladies and gentlemen. So let's take a look at our schedule coming up for the next couple of weeks. And so today we're going to develop and apply the chain rule, what I affectionately call the big bad mother daddy of them all, because it combines multiple derivative shortcut rules into a single derivative rule that allows us to handle composition of functions, more complicated functions. And so I'm super excited about that. It's the most powerful rule in my opinion. Next class cycle, we'll be looking at exponential derivatives, right, and some logarithmic functions, but exponential derivatives in particular. For us, the 15th, that Thursday before the no school day for parent-teacher conferences Friday, that Thursday, the 15th, we'll be receiving our Unit 3 concept and skill guide, right, and you'll have some time in class to work on your review. And so I've made some problems to practice with our new chain rule, the combined shortcut rules, for a little bit together in class, and then you'll have the rest of the class time to work on the review, and you can do that with a classmate. And then our test then for Unit 3, again, no school Friday. Our test is going to be Tuesday the 20th. 2 parts again. In the spirit of our AP exam, we've got 2 parts. The first portion is non-calculator. The second portion is calculator allowed. And the concept and skill guide will have a listing of those topics. I did include on our Moodle site, I created a new event on our Moodle course calendar, and I hyperlinked the concept and skill guide. If you want to get a jump ahead and see exactly what skills will be assessed on there, then you can just click on that hyperlink if you go to that new course event, Unit 3 test. You can see exactly what you'll be receiving a hard copy of on the 15th. So questions about where we are in our schedule for Unit 3? I just want to make you aware as we get as we come into the next couple of weeks. That's kind of our end goal there. We want to make sure that Unit 3 test is a great one. We'll also be having our Moodle discussion forums now weekly, and this next week coming up, you'll be charged with the task of replying to a classmate's particular post for points. So some of you replied this week to a classmate, and that's great. Remember, to get points for your Moodle discussion posts, you need to reply to my prompt by Thursday, 11:59 p.m. Moodle time, and then choose a classmate to reply to, right, by Sunday, 11:59 p.m. Moodle time, and to get your full points. 3 points plus 2 points is a total of 5, and that's an easy way to gain points outside of our regular classroom activities. It's also a great way to interact with the concepts and make up some real-world examples of where we can see our calculus concepts. And so I'm excited about that. All right, let's go ahead and make sure we have our conjectures taken care of, and we did that. So let's start our derivatives rule sheet. If you guys look at the backboard, we've gone ahead and started those derivative rules we've developed over the past week and a half. So I ask at this time that you go ahead and take out your own piece of paper. You're going to start your derivative rule sheet, and let's go ahead and make sure that we have all of those first derivatives down. I went ahead and wrote them in sort of an if-then format. And so if f of x is given by some constant k, then f prime of x equals 0. So let's go ahead and on our derivative shortcut rules, we can go ahead and make our own sheet. If you want to do it with like highlighter or pen, different colors, because this is a super important sheet to make. And you can also use it in one place when you start your derivative flashcards, right? Your derivative flashcards. I know some of you have already gone out. Walgreens gotten your neon flashcards so you can start your little baggie of derivative shortcut rules. So we've got our derivative of f of x. If f is a constant k, f prime of x is 0. If f is given by mx plus b, then f prime of x is n. If f is a sum of functions, u plus v, and f prime is the sum of the derivatives, u prime plus v prime. Your number 8 stamp from 3-4, an easier way to find the derivative function. If f of x is a constant times a function, then f prime is the constant times the derivative function. Our classic power rule. Power rule, power rule. If f of x is given by x to the n, then f prime of x is given by n times x to the n minus 1. And our latest additions, if f of x is sine of x, then f prime of x is cosine of x. Similarly, if f of x is cosine of x, then f prime of x is given by the opposite of sine of x. Those are our two latest derivative rules. We developed those last time in class, and we've got a good start for our derivative shortcut rules. Are these all of our shortcut rules? No. We're going to continue to develop shortcut rules over this next couple of weeks, and then we'll be combining those in some new forms to start Unit 4. We'll be looking at products of derivative rules, products of functions, quotients of functions, and some more applications. Okay, if you didn't get all those down, right, that's fine. You'll have an opportunity to continue working on your rule sheet, right, later in today's class period. We will have some work time today. But first, I want to make sure that we're comfortable applying those rules. And so as promised, right, we need to begin committing these shortcut rules to memory, right, so that you're able to apply them, right, at will efficiently. So, and now it's that special time. No, not that time, Kobe. It's time for mental derivatives. Yes, take 2, mental derivatives. And so now we've got our classroom numbers from last time. In just a minute, I'm going to use the random number generator from the graphing calculator to call on you at random. And if you're selected, remember you're going to share the derivative of the given expression, right, in front of your classmates in real time, and I can't wait for that. So everybody get ready. Here we go. The derivative with respect to x of 3x to the 11th, and we're 1 through, do we get to 24? 22? 29 in the other class, yikes. Get ready? Number 14.
33x to the 10th.
Siri says, you are correct. Very nice. Plus 10. Very nice. Next up, the derivative of 7 sine of x. 7 sine of x. Number 12.
7 cosine x.
Survey says, you are correct. Very nice. Plus 10. The derivative of 5 cosine of m with respect to m. Number 4. Here. Number 4 again. Oh, still not. Number 8.
5, negative 5 sine of m.
Survey says, you are correct. Negative 5 sine of m. Right? Nice. Derivative with respect to x of e cubed. Number 1. Oh, nice job, Sophia. Very nice. 0. Derivative of any constant is 0. Derivative of sine of x minus cosine x. Here we go. Oh, the pesky signs. Pesky signs. Nothing. All right, that's fine. It's been a long week. Number 20.
Cosine of x plus sine of x.
Yes, cosine of x plus sine of x. Nice job with the sine. Derivative with respect to x of cosine of x plus sine of x. Number 17.
Negative sine x plus cosine x.
You are correct. Good job. Very nice. Very nice. Okay, next. The derivative of negative sine of x plus cosine of x. Number 16.
Negative cosine x minus sine of x.
You are correct. Good job. Very nice. Good job handling signs. And I think our last one, derivative with respect to x of negative cosine of x minus sine of x. Number 21.
Sine of x minus cosine of x.
It's correct, absolutely. That's right. Good job, you guys. OSG, KIT, BFF. And so you guys are doing a great job with your derivative shortcut rules, and we didn't have any mistakes made with handling the negatives. And so I want to give a big thumbs up. Okay. Commit the shortcut rules to memory. Be ready to apply them, right, at will, efficiently, and quickly. And that's why we did the proof so that we can now use those forever after. All right. So today we're going to add our most important shortcut rule of them all, and that's called the chain rule. It'll allow us to handle when we have complicated functions, the composition of functions. We're going to be able to use the chain rule in order to find the derivative. And so today we're going to earn stamps at stamp eligible items number 5, 8D, and then at the end of the practice. We will be working on cooperative learning groups, and our timetable is a little bit different, but we do need to come back together to solidify our conjecture and have our closure. We'll need a little bit more than 5 minutes today, and so we're going to aim for about 8 to 10 minutes for coming back together. For us, that means we want to come together right around 11:34, right? 11:34, 11:35, and that should give us enough time for our closure. Okay, so we're aiming for around 11:35. I'll put that on here to remind me. Awesome. I'll go ahead and pause the recording now, and you guys can scoot in groups and get going right away. After I record your tails, I'll come around to answer questions that you might have and issue stamps. Thanks for getting going right away. Awesome. Thank you, ladies and gentlemen. Let's go ahead and take a look then at our chain rule activity. So the key here was determining what's my overall function, right, versus what's my inner function, so that the composition V of U of X produced my original. And so in the first ones, I saw you guys did a great job saying, oh, overall, is this a linear function or a trig function? Overall, this is a trig function. It's sine of X. It's sine of something. And then the something that's evaluated at is the inner function, U. In this case, that was 2 of X. It was also easy to see for letter B. My overall function, was that a linear function or a trig function? Well, it was a trig function again. My overall function, V, was cosine of something, cosine of X. Evaluated on my inner function, U, was now 1/2 X. And so you guys cruised through these first two. It got trickier when we looked at letter C and letter D, didn't it? So letter C is my overall function, a trig function or a power function, a squaring function. In order to determine that, I think it was helpful to rewrite K of X as sine of X quantity squared. Remember this sine squared X? That's shorthand notation for sine of X quantity squared. And now it's easier to see. My overall function in this case, is it a trig function, right? Or a linear function? No, my overall function in this case is not the trig function. It's a squaring function. The squaring function, X squared, something squared. So my overall function, V of X is X squared, evaluated at my inner function. U of X is the inner function, that's sine of X. Now the composition V of U of X would give me sine of X quantity squared. And so it was easier to rewrite that. And then you guys, again, was the overall a trig function or a power function for D? For D was the overall trig or power? Trig, so sine of X and
X squared.
X squared. Good job, you guys. All right, so let's put it all together. Our original sine of 2x, right? Its derivative there we saw. That gave me cosine of 2x and then times 2. So we had 2 cosine of 2x, right? Are we listing all these? They're all listed there. The cosine of 1/2 x went to negative 1/2 sine of 1/2 x. Right, is that what we got for that one? And then do we have Frank, was it? And so here we have sine squared x, and our derivative for that was a conjecture by Frank, and wasn't that 2 sine of x cosine of x? Is that right? And then lastly, the derivative of sine squared x, right, ended up being 2x cosine of x squared, right? So how could we then generate a rule for a generalized composition of functions? That is, v of u of x prime, right, the derivative of a composition of functions, And I saw many of you had proper notation here. I like to do the outside order first, so I do the derivative of the overall function, evaluate at my inner function, so v prime of u of x, and then times the derivative of my inner function. That would be times u prime of x. Now either order is correct. I saw many of you had u prime of x first, and then times v prime of u of x. But with our words, I think of the derivative of the overall function first, and then times the derivative of the inner function. Let's go ahead and do it. Can we do it with f's and g's? Certainly. Consider a composition of functions f of g of x. The derivative, then, of f of g of x would be given by the derivative of the outer function, evaluated at the inner function, and then times the derivative of the inner function. Let's see if we can make sense of that. So we had the derivative of sine of 2x is the derivative of the overall function. Sine of x goes to cosine, right? So sine of 2x will go to cosine of 2x, then times the derivative of the inner function. What's the derivative of 2x? 2. And so there it is. There's my 2 multiplier. Let's jump down to a complicated one. Sine of x squared. The derivative of my overall function, sine of x squared, right? Sine of something is cosine of that same thing. Then times the derivative of my inner function. What's the derivative of x squared? 2x, there it is. And lastly, the big bad mother daddy of them all, letter C. My overall function is a squaring. What's my derivative of a squaring function? Well, that would be exponent times the base raised to 1 less. So this is 2 times sine of x to the first. Then times the derivative of the inner function. What's the derivative of sine of x? Cosine of x. So that's how Frank was generating his. All right, let's go ahead and do it in words then, and that'll be helpful. So I know that the derivative of f of g of x is given by f prime of g of x times g prime of x, the derivative of the inner function. So the derivative of a composition of functions is the derivative of the outer function with the inner function, then, bless you, times the derivative of the inner function. Let's see if that makes sense. So the derivative of a composition of functions is the derivative of the outer function with the inner function inside, and then times the derivative of the inner function. Let's see. So the derivative of the composition was the derivative of the outer function with the inner function times the derivative of the inner function. Do we see it? Awesome. Now we can go ahead and verify this. We'll go ahead and pick our overall function would be a linear function or a squaring function for y. Would that be overall linear or overall squaring? Squaring, and the squaring utilizes the power rule when differentiating. I'd get exponent times the base raised to the 1 less. So for us, that would be the exponent was 2 times the base raised to the 1 less. What was my base? Well, my base isn't just plain x, it's evaluated with the inner function, that was 3x plus 1. Now, times the derivative of the base, times the derivative of the inner function. What's the derivative of that linear function, 3x plus 1? 3. Let's check this and see how it compares with our beginning of the activity and our belt. So I get the 2 times the 3 is 6 times quantity 3x plus 1, and that, of course, is 18x plus 6. How does that compare with the beginning of the activity? Very favorably. I love it. So are we good with our conjecture? Are you guys ready to practice? You can practice with your classmates. That's great. Try to stand up at the end, and we'll come together for closure. So we'll go ahead and resume. I'll pause the recording. Pause what you're doing. I'm going to resume the recording, and let's go ahead and take a look at our closure. So ladies and gentlemen, today we investigated how we differentiate a composition of functions. On everybody's closure slide, I want you to go to your closure for your day 8 notes, and let's go ahead and write down with f's and g's and x's what the derivative of f of g of x would be. Okay, so let's go ahead and write down what the derivative of f of g of x would be on your closure slide. And then let's go ahead and state that in words. So the derivative of a composition of functions is in words. Lastly, we'll apply that chain rule to our number 3 and number 4 closure exercises. We want to go ahead and then find the derivative of a composition of functions and be ready to share your results with the class. So this is homework, but it should be too long, and these ones right here are totally. Yeah, so they're like right around. Okay, ladies and gentlemen, at this time I ask that you go ahead and focus in on your closure exercises. I'm going to ask you to share your response with the class. And so what would this look like with primes and f's and g's and x's, the derivative of f of g of x? Meg?
F prime of g of x times g of x.
Excellent, thank you. So the derivative of a composition of functions in words then is the derivative of the overall function or the outer function with the inner function or evaluated at the inner function, and then times the derivative of the inner function. All right, let's apply it. Moment of truth. The derivative with respect to x of sine of x squared, right? What are we going to get there? Savannah?
Cosine x squared times 2x.
So the derivative of the overall sine goes to cosine, evaluated at the inner x squared, and then times 2x. Excellent. So I could rewrite this as, right, as Frank did, I get 2x cosine of x squared. Raise your hand if you had the same thing as Savannah. 2x cosine of x squared. Yes. And one to go. The derivative with respect to x of sine squared x, right? So derivative with respect to x of sine squared x. What would that look like? And Meg?
2 sine x times cosine x.
Absolutely right. Raise your hand if you had the same 2 sine x times cosine x. Please listen carefully in our last minute. Derivative interpretations. We've got a packet to practice interpreting our derivatives in context complete with units, much like the soccer jersey example, which we'll use as a springboard for our Moodle post next week in our discussion forum. Look for that prompt early Monday morning. I'll push out that prompt. Don't forget, if you unsubscribe from the forum, make sure that you put a cell phone reminder, right? To check Moodle, you've got to read the prompt and then respond with your original post by Thursday, 11:59 p.m. Moodle time. Include that half sheet of problems plus the derivative interpretations packet. Everybody, derivative interpretation packet is part of your OTL. So that packet, we interpret in context, and there's more than one right answer. Have a wonderful day. Thank you. And a great weekend, too. Have fun. Be safe.